Okay, today we're going to start off with combinatorics, something that you started covering in Algebra 2. We're just going to do a little bit of review and then move on from here this year. So we have a nice mathematical definition up here, and then we have a little bit more plain language down here. The only thing that the plain language isn't covering that the mathematical definition does is the fact that we can have more than two sequences, sequence of stages. We can have 1, 2, all the way up to n number of stages. So you might be multiplying more than just two numbers together. Just to make sure you're clear on the difference, because this can sometimes be confusing because we use combination in everyday language to mean something different than it does in math. Sometimes order matters in math. It doesn't matter in something like the different things that are going into a spirit box. It doesn't matter what order you say those things in, it's still the same. But a batting lineup would matter because putting player 1 before player 2 is different than putting player 2 before player 1. So something that you need to be aware of, and I want you to write this down in some notes or make a mental note of it if nothing else. Permutation is an ordered combination. We're actually going to start with permutations though. You could have permutations that allow repetition or permutations that don't. So if we allow repetition, we have 10 ways of making the first digit, 10 ways of making the second, and 10 ways of making the third, so we get 1,000 ways of making the combinations. If we do not allow repetition, so in this case, how many different ways can 10 students line up? Students can't be repeated once we put them somewhere. So we have, we have 10 students, 10 options for the first position, 9, then times 8, then times 7, then times 6, because each time we've already taken a student out of the lineup, so you can't repeat them. And so what we're doing here is actually something called a factorial. Hopefully you remember that. When you multiply a number times all of the numbers, all the integers that come before it, all the natural numbers that come before it. And it yields big numbers pretty quickly. So here's another quick example, one with repetition, one without. If we're doing the problem without, or where repetition is allowed, then we have 3 number digits, and we have 3 letters. There are 10 options for each number and 26 options for each letter. And we're just going to multiply those all together. I don't have to worry about when one has been used already. And I get 17,576,000. But if we do this with without allowing repetition, here's our 3 numbers, and then here's our 3 letters. I have 10 options for the first number, but then I only have 9 for the second and 8 for the third. 26 for the first letter, but then 25 and then 24 once I take out the ones I've already used. So then multiplying all of those together, and we get a much smaller number. So it makes a big difference. Make sure you're aware of the problem whether or not repetitions are allowed. So how many different permutations can be formed from choosing 6 letters of the alphabet. So take a second, pause, try that one on your own. And there's your answer. And here's looking at some of the notation here. I brought up factorials. If we're talking about how many permutations of an n set, and we're not giving specific objects to take out of that set, we just want to know how many permutations of an n set can be formed. So that's like writing out the long form of the factorial over here, but then the short way is just writing n factorial. So there's a formula for this. I'll talk about the formula in just a minute. Here's the important parts. N objects taken R at a time. This part can get tricky. And then here's our formula. And I want you to know that 0 factorial equals 1. So pause and make some notes of that. So just a quick explanation of that formula. Sometimes if we only want certain numbers out of a set, let's say I have 8 total objects in a set, but I only want to choose 3 of them. What I'm really trying to do is get just this piece right here. I want 8 times 7 times 6, but that's hard to, there's no notation for stop the factorial after 3 numbers. So what we do is divide by this factorial down here, because the 5s will divide out, the 4s will divide out, etc., and we're left with 8 times 7 times 6. So the best way of writing this out, using our formula, we start with the total and we subtract off how many we're choosing. And that will give us the truncated factorial, the factorial that stops. So here's a couple for you to try and figure out. I'll pause and then I'll give you the answers in just a minute. So there you go, there's some answers. I want you to try this one on your own. We'll go over the answers in class. This is the homework assignment that goes along with this video, so you should go ahead and try that. But remember, it won't be collected until the test. If you have any questions, don't forget to ask in class. Make sure you're jotting them down and make sure you fill out the Google Docs form.